This video describes how to draw an ellipse with a string in 2 tacks and what important things that tells us about an ellipse. You're about to see a very short 28-second YouTube video, so I want to introduce it so you'll know exactly what to look for when you watch it. You're going to see the 2 cross lines indicating that I have some dimensions of an ellipse. I want my ellipse to be have these vertices. In other words, I want it to have the dimensions as indicated by these arrows. So here are my dimensions of my ellipse. And for later on, let's just say that this is 50 feet and this is 30 feet. So let's just say for an example. What's going to happen in the video is you're going to see, I'm going to erase these little dots off here, you're going to see the person in the video put a little piece of string with loops on it and lay it across the length of what's called the major axis, or the longest direction all the way across the ellipse, or the longest diameter of the ellipse, you might say. Then the string is going to be removed, and the loops thereof, I guess, also. And you're going to see a person take a compass and make 2 little marks here and here. And those marks are and so they're going to use the compass, mark off this length from the center to the longer of the 2 vertices. That's that distance A, usually we think of. And then they're going to mark that distance off here and here. Okay, then the next thing you're going to see is they're going to take that string, that red string they had, attach it to those 2 marks. Let me put the marks back on. Here's the mark and another mark. You're going to attach it to the 2 strings, like so, and draw the ellipse with that. Okay, so we're going to watch that happen, and then we'll come back and talk about what does that tell us about the ellipse. Okay, watch carefully. This video is short. I guess I was wrong. They put the string on after they make the marks. Okay, we're going to watch it one more time because that was very short. Okay, exit full screen. Okay, here we go again. Okay, we're measuring the length of the distance to the larger, from the center to the larger side of the ellipse. We're marking that off then from the top. Those become the 2 foci. Now we're taking this the string, the length of the major axis, we're attaching it to the 2 foci, and then we're using that string to help draw the ellipse. Okay, so why is this important? Get rid of this, close that down, back to our smartboard. Okay, first of all, if the string is the length of the major axis, and then I attach the string to the 2 foci. So I'll put my 2 foci here, so we'll call this F1 and F2. And then I position the string like this, and I use it to draw an ellipse. I'll do the best I can with my ellipse here. Hey, that's not half bad. Okay, I know that the distance from all the way across here, we're going to call that distance A. This distance from the top to the focus is also A, because they mark that off with the compass, and also we know that the string, the length of the string is 2A, because we saw that it was stretched all the way across the ellipse. If I kind of move that string, it went all the way across. So that string is 2A in length. So when we position the string like I have now, each of these pieces is A. We also know that this distance straight up from the center is B. So I'm going to add another color here. So this distance from the center to the focus, which we call C, is related to A and B using a right triangle. And specifically, C squared is equal to a squared, I'm sorry, let me write that down better. Specifically, c squared plus b squared equals a squared, or c squared is equal to a squared minus b squared. So I can find the distance to the focus by doing this. I also know if I wanted to actually construct an ellipse that I would need to attach the two strings to the focus and how long that string would have to be. So often in a story problem, that kind of information comes in handy. Another thing that comes in handy in a story problem is if you're given the dimensions of the ellipse, and so I have these dimensions that I'm using, and I'm going to put an arrow on here. For some reason my cursor isn't working, or my, my mouse. The cursor on my mouse is not working, so I don't have anything to point with. So here's my dimensions, 30 high. So in other words, from here to here is 30. And 50 wide, so all the way across the ellipse is 50. Now how do I write the equation of an ellipse with those dimensions? Well, for a story problem, remember that we want to make this graph as simple as possible and as convenient as possible for us. So let's put the center on the origin. So assuming the center's on the origin, so I'll draw it down here. I think I'll scroll down a bit. So putting the center on the origin, if it's 50 across, that means I go 25 in this direction. This would be negative 25. And if it's 30, this would be 15, and this would be negative 15. So when I go to write my equation, I have to remember that the distance from the center out in the x direction is 25, and from the center out in the y direction is 15. So when I write my equation, I'm going to write x squared over 25 squared plus y squared over 15 squared is equal to 1. So notice we don't use the numbers 30 and 50 in the equation. We use half of those distances. I need my little arrow, my little pointer arrow. We use half of those distances because we only measure from the center out when we talk about how far we're stretching from the center. So there's 25 squared, there's 15 squared. So hopefully those two pieces of information will be helpful to you when you're doing some of the story problems. If you haven't watched the parabola problem, the bridge problem, the boat under the bridge problem, that's also, many of the ellipse problems have a similarity to that problem in that the ellipse, we're trying to compare another structure either within the ellipse or outside of the ellipse to the ellipse, and we need to actually compare coordinates of that other structure on a grid to coordinates of the ellipse. And once you have an equation for the ellipse here, then I could, for example, if I know an x coordinate, I could find a y coordinate. If I know a y coordinate, I could find an x coordinate to help answer a question in a story problem. So this will give you some tips for a story problem, hopefully helpful to you.